Hey everyone, so my name's Aparna. I'm Chief Product Officer at Arize AI, which is a startup focused on ML observability. My background, I previously came from the Uber ML team where I built out pieces of model deployment, model storage, and my work folded into Michaelangelo, which is kind of Uber's end-to-end ML platform. I have a technical background from Berkeley ECS and left my PhD from Cornell in computer vision to focus on what I think is a really important problem of how do you know that models are actually working in production, doing the right things, especially in this revolution toward more and more models coming to production. And so the problem that I wanted to start off focusing is really around, what is going on with ML observability today? Spoken to over hundreds of CEOs, data scientists, and data science leaders. And, if I could summarize what a ton of them are saying, it's kind of the quote at the bottom of this PowerPoint, which is, I spend millions of dollars annually on machine learning, and I have no idea if it's even working. And these set of questions boil down from, is the model that I've actually built in a research environment going to work in a true production environment? Is the model that I've actually built in production working? And not just working for a global view, but really if I look at specific slices or specific groups of the population, is my model working for those specific slices? And if there are issues, identifying what's wrong with my model and why is a really tough problem today. And when I think about the differences between the software development lifecycle today and the model development lifecycle, it's pretty obvious that there's vast differences in the way that these two work. And so in the software development lifecycle, a lot of effort into actually building tests and integrations to make sure that that piece of code works as expected in a production environment. And then when that code's actually pushed into production, a lot of tools to actually help you monitor and maintain it in production. If I look at the model development lifecycle, there's still pieces of this that are not as fully baked and are very light. And so, today there's almost two different people who really own this process. There's maybe a data scientist who actually builds the model and an ML engineer who actually puts that in production. And the person who actually puts it in production, there's not a lot of tools to actually help you do this validation and testing to make sure that it's working in a real prod environment with different feature inputs and feature pipelines coming in. And not a lot of great tools to actually help you monitor to be able to understand things like distribution shifts and model drift. And so what that leads to is these production challenges that we hear, ML engineers and data scientists complain about a lot, which is model drift. How do you know if your model, has changed over time, whether features change, data has changed, or the model itself, the performance has drifted, data distribution changes. Maybe you're seeing values for a feature that you've never seen before when you actually trained your model, black box models, not knowing why your model performed the way that it actually performed, general data quality issues, and overall model readiness. How do you know if sort of the model that you have that you're building is better than the next model that you're sort of working on? So sort of these kind of broad production challenges, there's a broader set. Model bias is one of them. And so, these are kind of problems that people see in production because of the lack of tooling focused on sort of validation and monitoring. And I wanted to highlight, especially in sort of this current ecosystem that we're in, coronavirus, people are calling it the Black Swan of 2020, but just really an unexpected event that has happened. And a lot of folks are seeing that their models are starting to perform really poorly in production. And so this makes sense if you think about, the changes that these models are actually seeing. You're starting to see unemployment numbers are the worst since sort of the Depression era. You're seeing that this kind of unemployment impact, which might be an input to some models, the range that we're seeing right now is maybe calculated to happen once every 100,000 years. And so it's a truly anomalous outlier event that is feeding into some of the models that the folks have told us about. There's huge traffic impacts that we're seeing. Traffic is probably at 1 to 10% of the daily volume since before COVID. And what that does is all of these, weather forecasts, whether it's banking models, are all struggling to handle sort of these varied inputs that are coming to the model. And so now is even greater of a time than ever to really think about how do you build resiliency into your production machine learning efforts and make sure that they're actually keeping up with sort of the changes in the outside environment. And so I wanted to talk a little bit about Arize. Arize is a startup focused on ML observability. The team comes from folks who have built ML platforms at places like Uber and Google and Facebook. And the places where Arize focuses on is really around, a set of tools to help you validate your model before it goes into production and analyze and troubleshoot any prediction behavior on any slice of predictions. And then a set of tools to actually make sure that it's working in production as expected. And so learning and monitoring so that you can deliver models like you deliver software. And then if there are any issues happening with the model, tools to actually help you troubleshoot and explain any things that could be happening. And the way that Arize is built, we capture the inputs to the model, we capture the outputs, and we tie back the actuals to actually give you real-time performance tracking and alerting. If you want to reach out and hear more about Arize, please email me at aparna@arize.com. Happy to go much more in detail than I could in this 5-minute pitch.